Let z be a non-zero complex number and suppose that w is a rational number. Show that the two possible definitions of z to the w are equivalent. And before we get started, let's recall what the two definitions actually are. There's one definition that is based on de Moivre's theorem. So suppose that z is equal to r times cosine theta plus I sine theta, or written more compactly, this is equal to r times e to the I theta, where theta is an angle between, sorry, I got my Greek letters mixed up, negative pi and plus pi. Then there are two definitions. The first definition is that z to the w is equal to r to the w times the cosine of w theta plus I sine w theta. And that's based on de Moivre's theorem. This is not a theorem for rational numbers, that's a definition for rational numbers. The second definition of taking a complex number to a rational exponent is to say that this is equal to e to the w times the log of z. And we will now show that these two things are actually equal. To do this, we note that the definition of the logarithm of a complex number is equal to the natural log of r plus I theta. That's what it means to be the logarithm of a complex number, where theta again is in the specified range. So this is equal to e to the w natural log r plus w times I theta. And because of the additive property, the law of exponents works, one of the laws of exponents works for the exponential function, that e to the x plus y is equal to e to the x plus e to the y, even if x and y are complex numbers. So I can write this as e to the w natural log r times e to the I times w theta. And that's because we have the theorem that says that this property remains true even if the exponents are complex. Okay, so this is equal to e to the natural log r to the w. Because natural log r and w are real numbers, I can use the ordinary law of exponents for rearranging the terms here. And the e to the I theta part, or e to the I w theta part, is equal to cosine of w theta plus I sine w theta. And so this is equal to r to the w times the cosine of w theta plus I sine w theta, which is the first definition that we have in red up here. So the two definitions are equivalents, which we can take some satisfaction and relief in, that these two different looking things actually mean the same thing as long as if w is rational.